The morning of May 10, 2025 began like any other. People woke up, coffee brewed, radios hummed with morning news, then something extraordinary happened. Our sun unleashed a tremendous burst of energy. This was no ordinary sunrise. It was a solar flare, a powerful explosion on the sun's surface. Its effects rippled across space, reaching Earth in mere minutes. Suddenly, parts of our world felt a strange silence. Imagine you are listening to your favorite radio station. Suddenly, static. Or you are a pilot relying on communication. Suddenly, silence. This was the reality for many across Europe and Asia. High-frequency radio signals, the kind used for long-distance communication, simply vanished. The sun had, in a way, shouted so loud that it drowned out our whispers. This wasn't science fiction, this was real. It was a stark reminder of the sun's immense power. Scientists around the globe pointed to our star. A specific region on the sun, a turbulent area of magnetic activity had erupted. This wasn't an attack or a malfunction, it was a natural phenomenon, a solar flare of significant strength. So what is this phenomenon? A solar flare? Think of the sun as a dynamic, churning ball of superheated gas and plasma. It has a powerful magnetic field. Sometimes these magnetic field lines near sunspots become incredibly tangled and stressed. When these tangled magnetic fields snap and reconfigure, a colossal amount of energy is released. This sudden, intense burst of radiation is a solar flare. It shoots out radiation across the entire electromagnetic spectrum. We see it as a bright flash of light, but it also includes X-rays and extreme ultraviolet radiation. The energy released in a large flare can be equivalent to billions of hydrogen bombs exploding all at once. These flares occur in the sun's atmosphere, from the photosphere up into the corona. The light from a flare travels at the speed of light, reaching Earth in about 8 minutes. Understanding this process helps us appreciate the sun's active nature. It's not just a passive source of warmth, it's a celestial powerhouse. Therefore, a solar flare is essentially a magnetic explosion on the sun. It's a fundamental process driven by the star's internal dynamo and its ever-changing magnetic fields. Scientists classify solar flares based on their X-ray brightness, measured by satellites. Think of it like a Richter scale for earthquakes, but for solar explosions. The classes are A, B, C, M, and X. A-class flares are the smallest, like tiny firecrackers. B-class are a bit stronger. C-class flares are minor and usually have little to no effect on Earth. M-class flares are medium-sized. They can cause brief radio blackouts. Then there's the X-class. These are the giants, the major explosions. The May 10, 2025 event was classified as an X2, 7 flare. The X tells us it's in the most intense category. The number 2.7 gives us a more precise measure of its strength within that category. An X2, 7 flare is a significant event, nearly 3 times more powerful than an X1. This level of intensity means that the burst of X-rays and extreme ultraviolet radiation hitting Earth's upper atmosphere was substantial. The X2, 7 flare of May 2025 didn't waste time making its presence felt. As its intense X-rays and UV radiation slammed into Earth's upper atmosphere, the effects were immediate, particularly for radio communications. High-frequency radio signals, those used by amateur radio operators, international broadcasters, and aviation for trans-oceanic flights, experienced a sudden blackout. This occurred primarily on the sunlit side of Earth, which at the time included large parts of Europe, Africa, and Asia. For up to an hour, these vital communication links were severely degraded or completely lost. Imagine pilots flying over vast oceans, suddenly unable to reliably contact air traffic control. While aircraft have multiple communication systems, the loss of HF radio is a significant concern. It can lead to rerouting of flights, delays, and increased workload for flight crews. Beyond radio, global positioning system signals can also be affected. The same atmospheric disturbances that block HF radio can also cause fluctuations in GPS signals, potentially reducing their accuracy. For precision agriculture, surveying, or maritime navigation, even small errors can have significant consequences. The May 2025 flare prompted checks on critical GPS-dependent systems. These disruptions, while temporary, underscore our reliance on technologies susceptible to space weather. The May 2025 flare served as a practical, real-world stress test for our systems. Our sun isn't static in its activity, it has a heartbeat, a rhythm. This is known as the solar cycle, an approximately 11-year period during which the sun's activity waxes and wanes. We go from a solar minimum, a time of relative quiet with few sunspots and flares, to a solar maximum, a peak of activity with many sunspots and more frequent, intense solar flares. The May 2025 event didn't happen in a vacuum. It occurred as we were approaching or were in the midst of a solar maximum for solar cycle 25. The source of this particular X2 7 flare was identified as sunspot region AR 4087. Sunspots are regions of intense magnetic activity, cooler than the rest of the photosphere. These are the breeding grounds for solar flares and coronal mass ejections. AR 4087 was a particularly large and magnetically complex sunspot region. Scientists at observatories around the world and in space constantly monitor these active regions. The behavior of AR 4087 had been watched closely in the days leading up to the flare. Understanding the solar cycle and the nature of sunspots like AR 4087 is crucial for forecasting space weather. Often, powerful solar flares like the X2 7 event are accompanied by another, even more potent solar outburst, a coronal mass ejection, or CME. While a flare is an intense burst of radiation traveling at light speed, a CME is a colossal bubble of plasma and magnetic field lines hurled from the sun's corona into space. These CMEs travel much slower than flares, taking 1 to several days to reach Earth if they are aimed in our direction. Following the May 10th flare, scientists immediately began looking for signs of an associated CME from region AR 4087. If a CME does erupt and heads towards Earth, it can have some beautiful consequences. The charged particles from the CME interact with Earth's magnetic field and atmosphere, creating spectacular auroras, the northern lights and southern lights. A strong CME can push these auroras to much lower latitudes than usual. This is one of the more benign and awe-inspiring effects of solar activity. However, the beauty of auroras comes with a more ominous side. A direct hit from a powerful CME can be far more disruptive than the flare itself. The influx of charged particles can induce powerful electrical currents in long conductors on Earth, such as power lines and pipelines. This can overload power grids, leading to widespread blackouts. Satellites, which are outside the protection of much of Earth's atmosphere, are particularly vulnerable to damage from CMEs. The threat to our power grids and satellite infrastructure from a strong CME is a serious one. Fortunately, we are not blind to these solar tantrums. Agencies like NASA and NOAA in the United States, along with similar organizations worldwide, constantly monitor the sun. They use a fleet of sophisticated satellites, such as the Solar Dynamics Observatory and the GOES satellites, to watch for flares, CMEs, and changes in solar wind. Their work is crucial for providing warnings and forecasts about space weather. This gives us a chance to prepare. The May 2025 flare, while disruptive, was not catastrophic for most people on the ground. The Earth's atmosphere shields us from the harmful X-rays. However, astronauts in space or passengers and crew on high-altitude polar flights could face increased radiation exposure during such events. Historically, there have been much larger solar storms. The Carrington event of 1859 was an incredibly powerful solar storm. If a Carrington-level event hit us today, the impact on our power grids and technology could be devastating. So, what can ordinary people do? Firstly, stay informed. Follow updates from official sources like NOAA's Space Weather Prediction Center. The most important thing is awareness. The sun is our life source, but it's also a variable star with a dynamic personality.